It's important to note here that for every effect that we are using on an asset, we are using up a little bit more CPU power at runtime. However, we're saving RAM space, so this is a balance that you're going to have to figure out according to your own needs. So far, we've looked at the various kinds of effects that you can place on top-level containers or any container within that tree structure. But there is another way that you can use effects as well that we haven't looked at all yet. You'll notice that any container is by default routed to the master audio bus. That means that when we trigger the sound, before it reaches our ears, it is always routed through a main bus. And that bus can be found up here. This is essentially your master volume. You can reduce this and it will reduce the volume of any item that we have created because by default they are all routed directly out of the master audio bus. However, this is not necessarily going to be your final setup. There are a lot of advantages to routing your sounds out of smaller buses that you have created specifically for certain types of sounds. There are two types of routing that you can create in the master mixer hierarchy. There are audio buses and aux buses. The difference between these is that an audio bus is something you directly route the output of your containers through. Let's start by taking a look at that. Inside my master audio bus, I'm going to create a new audio bus and I'm going to call it ambiences. In reality, it would probably make sense for you to create different ambience buses according to each of your locations or scenes or levels, but in our situation, just one is perfectly sufficient. So next, we're going to want to go in here and route each of our ambience containers through the ambiences bus. Now the output bus of all of our ambiences is set up to go through the ambiences audio bus. So let's take a listen to this. So you can see that the volume, and also we will have control of things like pitch, low pass filter, and so on. All of this will be controlled at a top level because this is our mixer interface. And so anything that we route through this bus, we can control with this top level setup of controls. Be aware though, that anything we change here will affect all of its children that are routed through it. So you really only want to be doing final top level mixing controls up here. Of course, this leads us back to effects. You can see that our audio bus has an effects tab, and we can place effects here that will affect anything routed through it. So you have to be careful here. You don't want to be doing anything complex. You don't want to be doing anything that you don't want affecting everything that comes through this audio bus. But for certain types of effects, this will be very useful. Now there's something else I want to look at, and that is the aux bus. The aux bus is a little bit more flexible. Let's call this one Big Hall. The difference for the aux bus is that rather than routing your signal directly through it, you can choose to duplicate your signal and send a portion of that through the aux bus. Let's take a look at that. We'll come back to our door for this purpose. So we have a big door here, and let's say we want this big door to sometimes sound like it's in a big reverberating hallway, but not always. For this purpose, it's better to leave it routed out of the master audio bus and then set up something down here in user-defined auxiliary sends. Here, you can set up an auxiliary bus send. So we can just go ahead and select Big Hall. And now you will see that a split signal will come off of the main signal, which is still going through the master audio bus, and that split signal will also be routed to the auxiliary bus. Let's take a look. So if we select that now, we can see that these levels are running through the Big Hall auxiliary bus and the master audio bus. Now, by default, a volume of 0 means that the same volume of audio that is going out the master audio bus is also now being sent to the auxiliary bus. However, this can be a little bit dangerous, especially if you have effects on that auxiliary bus. You probably don't want to be hearing that all the time, hence the use of the auxiliary bus. So I would recommend dropping this down to a level that cannot be heard. I'm going to use -96, which is often a default within the Wise setup. And now when we send that out, you see that we are not seeing any listenable levels coming through that aux. And of course, we can now use RTPCs to control that and bring it up to the volume that we need when we want to hear it. So now let's take a look at the effects. We can place on the Big Hall auxiliary bus a verb effect. Let's use something nice and reverberant. Maybe even bigger than that. That sounds like it needs a little bit more pre-delay. So it's not separated so much from the sound. Let's try this. And let's now reduce the overall reverb length a little bit. Perfect. So let's say we've got our setup, we like the way that sounds, but we only want to hear this when the player is in specific types of rooms. So of course, then we would set up an RTPC, and that RTPC would change the amount of this signal that is being sent to that aux bus. We could even, if we wanted, really exaggerate it. And so you see, effects don't have to sit directly on audio containers. We can put them on auxiliary buses, we can put them on audio buses, and still all of these effects can be controlled fairly elaborately by RTPCs. So in combination, using effects, gain parameters, and also aux sends, you can really create some elaborate structures, some dynamic sounds working together, taking the information that you're getting from the game, the player's actions, and creating a really dynamic, responsive sound design.